Welcome guys, here is another proof for another theorem in mathematics, and today our theorem will be about the sine rule theorem or the sine rule formula, which states that if we have a triangle like this, so if we have a random triangle like the sides A, B, or just not make this, it will be like this. We have the vertices A, B, C. So this is AC, this is AB, and this is BC. So this is A, B, and C. The sine rule states that sine of A divided by BC is equal to sine of B divided by AC equal to sine, okay, just like this, sine C divided by the side AB. This is the formula of the sine rule. This is the formula. So what we're gonna do now, we are just going to prove it. So what is the proof? First, let's just take this, and yes, now let's start. If we have a random triangle A, B, and C, the vertices are A, B, C, and the interior angles are A, B, and C. This side is AB, this side is AC, and this side is BC. If we took the vertex A and goes down perpendicular on the side BC, so this is the height of the triangle, one of the heights or the altitudes of the triangle. So okay, let this point be like E. So just let's raise it. So here we have AE is perpendicular on the side BC. What we have now, we have here, we made two triangles, two right angle triangles, the triangle AEC and the triangle AEB, and for some, and just to be in the photo, they are not congruent, or they are not congruent, okay? So what we have here in the triangle A, E, and C, we have AC and EC this side, and AE is common side in the two triangles. The triangle ABE is AB, AE, and BE. So what we have, if we took the sine of angle C, the sine of the angle C, what we have, sine of C is equal to the opposite side divided by the hypotenuse. So the opposite side is the side AE, so it is equal to AE divided by the hypotenuse, which is again the side which is opposite to the 90-degree angle, which is AC. That's beautiful. So states that this like as number one. In the other triangle, if we took sine the angle of B, sine of angle B, if we took it, the opposite side is also AE and the hypotenuse is AB. So sine of B is equal to AE divided by AB, and this is number 2. So if you look to these both equations, if we just make cross multiplication in both of them, we get that in number 1, from 1, we get that AE is equal to sine of angle C multiply AC, and from 2, therefore we get that AE is equal to sine of angle B multiplied by AB. And so, since the AE is common between, between the two equations, so sine C multiplied by AC is equal to sine B multiplied by AB. So we get that, therefore, sine of C multiplied AC is equal to sine B multiplied by AB. So after we got to this form, what we are going to do now, just we want to make it in the form of equal ratios, as the formula states. But this is true, but we wanted to make it easier or in a better form. So what we are going to do first, we are going to divide by AC in both sides. So this will be cancelled with this. So sine C is equal to sine B multiply AB divided by AC. And now we are going to divide both sides by the side AB again. So this will be divided by AB and this divided by AB. So sine C divided by AB is equal to sine B, and if you don't know, this will be cancelled, divided by AC. And this is the first form we got, and we really need it in the second step we are going to do. So the second one, if we have a triangle like this, the same triangle with the same angles. So last time we made an altitude from the vertex A to make a perpendicular side on the side BC. But now we are going to take the vertex B or the vertex C, it doesn't matter. But for example, we are going to take the vertex B and make a perpendicular projection on the side AC. So this is an altitude or height for the triangle. So this is, let it be the vertex Z. So this is BD, this is 90 degree, and this is also 90 degree, AB and BC. So we are going also to make the same thing. So sine C equal to the opposite side, which is BD, divided by the hypotenuse BC. So BD divided by BC. And the same thing with the angle A, the sine of angle A. So sine of angle A is equal to the opposite side, BD divided by AB. BD divided by AB. Now we are going to make cross multiplication. So this is equal and this is also equal. So BD in both sides will be equal to sine C multiply BC. You can say, but okay, BD is equal to sine A multiply AB. So since BD is equal to BD, so this is equal to this. This is equal to this. So let's write it down. We have sine A multiply AB is equal to sine of C multiply B. See, and just let's zoom in again like this. What we are going to do, again the same thing, divide by B like this, and this will be cancelled. So sine A is equal to sine C multiply BC divided by AB, and just divide both sides by BC again. So this will be cancelled, and we got the final form, which is sine A is divided by BC is equal to sine C divided by AB. This is number 2. Let's zoom out again and go back to our first formula, which is sine C divided by AB. If you look, we have it again. We have the both formulas again. So since sine C divided by AB is equal to sine A divided by BC, and also is equal to sine B divided by AC, so they are all equal. So we got to the final form of the formula, which is we have like this: 3 fractions or 3 ratios. Sine of angle A divided by BC is equal to sine of angle B divided by AC is equal to sine of angle C divided by AB. And this is the final form of the formula of the sine rule. So I hope the proof was easy, but tell me in the comments if it was useful or not, and thank you and goodbye.